Okay, so what we'll do is do some examples now of vectors and scalars. So the first one here, we have a plane flying along in this direction here with a speed of 66 meters per second. Now, coming from the side, there is a wind. Okay, now what we're going to do, we're going to calculate what the actual velocity of the plane is going to be. You'll actually see that the plane is going to head off in a certain direction. That's off to an angle, and it's actually going to go slightly faster. Now, how do you work it out? Remember, you've got to add the vectors head to tail. So what you're going to do is you can draw. So we're finding final velocity or actual velocity. Okay. Now, what we're going to do is add the two vectors together. So you could actually first put in a scale. So in this case, we're going to have 1 centimeter equals 10 newtons. So what we're going to do is draw a vector that is 6.6 centimeters long. Then going to draw another vector that is 1.4 centimeters long. And then we're going to draw our resultant. Now remember, the resultant goes from the initial first tail to the very last head. Okay, double arrow. So this is going to be about a 5-mark question. Double arrow, and then we'll measure the new length, and you'll find that it equals 6.75 centimeters. Okay, so that means the answer is going to be 67.5 meters per second. Now you also need to give an angle, so the angle will be equal to 12 degrees if you use a protractor. Now here's another one. Say we had a tree and we're pulling this side with a force of 50 newtons, this one with 25 newtons, with an angle of 10 degrees. Now when you work this one out, you can do this one yourself. I will just show you what to do. You're going to put in a scale, remember, so in this case scale will be same again, 1 centimeter equals 10 newtons. Should we make it a bit bigger? Should we make that 500? So 250 and 500. So let's make that 100 newtons is every 1 centimeter. So the first one you go for 2.5 centimeters, and then you get a protractor out and you add head to tail. So you're going to add one on here that is 5 centimeters, but it's at an angle of 10 degrees from the horizontal. And then you put in your final resultant vector and measure the length, and then measure the angle.